Right, folks, we are going to look at the topic of air pollution. Air pollution is one lesson in the topic of combustion. And we're going to quickly recap what combustion is. We're going to look at how the products of combustion may be a problem for us and the environment and the animals in it, and how we can reduce those negative effects of the combustion products. So, first of all, combustion is a scientific word for burning. So, when we take a fuel and we react it with oxygen, like we do with Bunsen burners, this is combustion. And there are two types of combustion we need to be aware of. The first one is this equation here. So hydrocarbon plus oxygen reacts to give carbon dioxide and water. This is complete combustion. So we are taking our hydrocarbon and we are reacting it completely with oxygen. There is loads of oxygen available, and all of the atoms in the hydrocarbon are reacting with oxygen fully to give us two products, carbon dioxide and water. This is a problem because carbon dioxide is a greenhouse gas. So whenever you are driving in our cars, or wherever we're doing anything where we are burning a hydrocarbon, that releases carbon dioxide in the atmosphere, and that is trapping warmth, trapping heat in the atmosphere, and contributing towards climate change and global warming. Second type of combustion we need to be aware of is incomplete combustion. And this is where we try to burn a fuel, hydrocarbon fuel, but there isn't enough oxygen present. So we don't just get carbon dioxide and water because the hydrocarbon is only partially oxidizing. So we get hydrocarbon plus oxygen, and this time we are getting carbon monoxide, as well as some carbon dioxide, water, and soot. Now, carbon monoxide is a toxic gas. What it does, it binds to your red blood cells, and if carbon monoxide is bound to your red blood cell, that red blood cell can no longer carry oxygen. So that's why your house will have a carbon monoxide meter to make sure that your gas boiler, which is burning a hydrocarbon gas, methane probably, is not producing loads of carbon monoxide or any carbon monoxide and causing your ability to carry oxygen around your body to be reduced. Soot particles are just pure carbon and are produced in diesel engines, and it's just carbon that hasn't reacted with oxygen at all. It's what you get when you burn a Bunsen burner on an orange flame, and you'll notice that the stuff above the flame gets a kind of black dust on it. That black dust is soot. It's just carbon that hasn't burned in oxygen. Right, very quickly. So far, pause the video, answer these questions. What are the two types of combustion, and what pollutants are products of combustion? Welcome back. So we've seen two types of combustion. We've seen complete combustion, where there's loads of oxygen and we get carbon dioxide and water, and incomplete combustion, where there isn't enough oxygen and we get carbon dioxide and water, but we also get carbon monoxide and soot. And the pollutants we've seen are carbon monoxide, soot, and carbon dioxide. I've put carbon dioxide in brackets because we do actually need some carbon dioxide. Some carbon dioxide in the atmosphere is excellent. We 100% need it. Plants need it to make food, and we need it to keep the earth not freezing. But too much of it is a bad thing, and that's the situation we're in now. This isn't the whole story, though. So there isn't just those two reactions we need to be thinking of. First of all, hydrocarbon fuels have impurities in them. So there are other things in hydrocarbon fuels that also get combusted when we burn the hydrocarbon fuel. The first one of these is sulfur. Sulfur is an impurity in fossil fuels, and when it reacts with oxygen, we get sulfur dioxide, according to this equation. Sulfur plus oxygen reacts to give sulfur dioxide. Now, this isn't great because sulfur dioxide is a gas. It is released into the atmosphere, and it dissolves in clouds. Clouds are made of water. It reacts with the water, and it makes sulfuric acid, according to this equation. Sulfur dioxide plus water reacts to give sulfuric acid. Now, what we have now is very acidic cloud water, which isn't good. Normal cloud water is a little bit acidic because carbon dioxide dissolves in it, and that's fine. So normal rainwater is a little bit acidic, and that's not a problem at all. But when we get very acidic cloud water, because sulfuric acid is being made in it, we call this acid rain, and this is a problem. And it gets worse. There isn't only oxygen in the air. So we've been acting like there's only oxygen in the air to react with our fuels, but there are other gases. The main one of these is nitrogen. Nitrogen is about 78% of the atmosphere. And in the high temperatures of engines, so when you're running your car, it gets very, very, very hot. The nitrogen and the oxygen react together to give you nitrogen oxides. So according to this equation, nitrogen plus oxygen react to give nitrogen oxides. And just like the sulfuric acid, the nitrogen oxides rise up in the atmosphere. They go into clouds, react with the water in the clouds, and give us nitric acid, which again is a very strong acid and gives us very acidic rain. Rain, it's not good news. If you're a plant or an animal, you have evolved to live within certain pH ranges. So if you're a plant, the soil you're in needs to be a certain acidity for you to be able to live and thrive. If you are a fish in a lake, you've evolved at that lake being a certain pH. If you're in a river, again, living things need a certain pH range to live. And if we dump a load of acid from rain on those environments, that is going to be very bad for those environments. So what can we do? First of all, answer these questions, please. So, which two gases cause acid rain? Which gases are produced by the reaction of an impurity in fossil fuels? And which gas needs the high temperature of something such as an engine to be produced? And here's your answers. So, gases cause acid rain are sulfur dioxide and nitrogen oxides. Which gas is produced by the reaction of an impurity in fossil fuels is sulfur dioxide. And which gas needs the high temperature of something such as an engine to be produced? Nitrogen oxides. They're also produced in lightning strikes as well, actually. But anyway, that's not relevant to the topic. So, dealing with pollutants from combustion. So, how we deal with it depends on where the pollutants are coming from. So, if we're burning our hydrocarbon fuel in a vehicle, such as a car or a truck or a van or something, all of those things will have catalytic converters attached to them, which is part of the exhaust. So, if you've ever seen an exhaust, the big long metal tube, basically, it comes out the back of a car, but there is a kind of boxy bit, a kind of rectangular bit in the middle of it. That is the catalytic converter, and what that does is it takes the nitrogen oxides produced in the engine and it converts them back to nitrogen and oxygen, which is good news. It also converts the carbon monoxide into carbon dioxide. Carbon monoxide is very, very toxic, so if you live in a city or a town and there's lots of cars going past your house the whole time, you don't want to be breathing in toxic gases the whole time. So obviously carbon dioxide is bad, but the toxic effects of carbon monoxide are very, very bad, and if you're growing up in a city, you don't want to be dealing with that. So it converts the carbon monoxide into carbon dioxide. In vehicles, we're only allowed to burn low sulfur fuels now, so fuels that don't have many impurities to begin with, and then diesel engines have filters to capture the soot that is produced. If you're a factory, we can stop the acidic gas, or a lot of the acidic gases being released into the environment using neutralization reactions. We're not going to recap what a neutralization reaction is. Suffice to say that acid plus alkali gives you a salt plus water, and that is the reaction that we will be doing. So we will take the acidic gases that will go into the atmosphere, but before we release them into the atmosphere, we will react them to stop them from being acidic, so what gets released isn't acidic and doesn't cause acid rain. If we've gone beyond that point and we are an environment that has been subject to too much acid rain, what we can do is use neutralization reactions again. For example, if you're a farmer and you want to grow a crop and the soil is now very acidic because it's had lots of acidic rain dumped on it, acid rain dumped on it, you can put something like calcium carbonate on your soil and do a neutralization reaction, and that will reduce the acidity in the soil. You have to be very careful doing this, though, especially if you're going to add it to something like a lake or a river which has been subject to acid rain, because it is very easy when you kind of tinker like this to just get it a bit wrong. But that's what we can do to try and undo some of the damage done caused by acid rain. So here's your key questions from the topic. I'd like you to pause the video and answer as many as you can. I'll put the answers up on the next couple of slides. Right then, just to recap. So we've looked at what combustion is. We've looked at the products of combustion, the problems they might cause, and how we might fix them. How to revise. I would start by making flashcards using the key questions. And then, because air pollution is only one topic, one lesson within the topic of combustion, start to bring together the key questions from this lesson and bring it together with the concepts from your other lessons. Using the mind map or a concept map or something like that. If you are stuck on how to do that, ask your teacher and they will give you some keywords and some guidance on how to do that. Thank you very much.